Welcome my dear students in Prep 3. Let's continue our algebra lessons. Our session today is about the symbolic representation of the function and the polynomial function. At first, if we have a function, this function is usually denoted by one of the letters. It can be F, G, or K, or N, or whatever. Okay? It can be mathematically written as, like here, can you see? F. Okay, this is a function f from x to y. Function f from x to y. Okay, if you have an ordered pair x and y, this ordered pair belongs to the function. It means that y is the image of x by the function f. Okay, so y is the image of x by the function f. For example, if you have a function f of x, for example, equals 2x. It means if you have x equals 1, so f of x will be 2. 2 times 1 is 2. So f of x here equals 2. F of x is the same as y, so y is the same as f of x. Okay, so the image of x, if x equals 1, is 2 times 1, which is 2. And this is the image is the same as f of x. Let's continue. Also, we can use this symbol, and it can be read as f maps x to y. F, it means the function f maps x to y. It means x and y is the image of x, or x related to y. Okay, or like here, f of x equals y, the same. They are all the same meaning, but you can use any symbol you want. Okay, here for example, if we have a function f relates x to y, or this is the rule of this function is f maps x to x power 2. It means if you have an ordered pair x, and then y will be x power 2. For example, f maps 4 to 16. Why 4 to 16? Because 4 power 2 equals 16. So f maps 4 to 16. If it's not 4, if it's 5, 5 power 5 equals 25. So f will maps 5 with 25, 6 with 36, and so on. Also, it can be written like f of x equals x power 2. F of 4, instead of x, I write 4. F of 4 equals 16. Okay? And this is called the rule of the function. So the rule of the function f is f of x equals x power 2, or y equals x power 2. Okay? Let's continue. We have some notes here. If we have a function f from set x to set y, it means that f relates x to y, then x, which is the first set, is called the domain, the second set, or y, called the codomain. Okay, the set of the image of the elements x by this function is called the range. So what is the range? It is the set of image of the elements of x by using the function f. Okay, and as we noticed, or as we said before, that the range is a subset of the codomain. Let's take an exercise. Here we have two sets, x and y. X consists of 2, 4, 6, and 8. Y consists of 1, 2, 3, 4, 5, and 6. And we have a function f relates x with y, where f of x equals half x. Okay, write the set of the function f and represent it by the Cartesian diagram, then find its range. So we want to write the function as an ordered pairs. as we wrote before the relation, okay? Then represented by Cartesian diagram, we know the Cartesian diagram. Then I'll find the range. Okay, let's begin. Here we have f of x equals half x. Okay, what is f of 2? We have, for example, let's begin with each element. The first one, f of 2. f of 2 equals half 2. Half times 2, which is 1. Half 2, which is 1. So 2 will be related with 1. This is the first ordered pair. By the same way, 4, yes, will be related with 2, 6 with 3, and 8, half 8, which is 4. Okay, so this is the relation. The relation will be 2 and 1, 4 and 2, 6 and 3, 8 and 4. Okay, now we have the ordered pairs, which we wrote here is the function f of x. The function f of x, which is f of x equals half x. Okay. Okay, this is the first required, which is write the set of function f. Okay, let's represent it by the Cartesian diagram. Do you remember? Okay, the range here will be y. 1, 2, 3, and 4. Okay, so the range is the images, only y. And we can draw the Cartesian diagram. Here we have x, 2 and 4, 6 and 8. Y, 1, 2, 3, 4, 5, and 6. Okay, and I'll put or locate a point for each ordered pairs. 2 with 1, this is the first point. 4 with 2, the second point. 6 with 3, and 8 with 4. Okay, this is the function. What about polynomial functions? What are the polynomial functions? Okay, the polynomial function is a function whose rule is a term or an algebraic expression in which we have two conditions here. Each of the domain and codomain should be the real numbers, and the power, okay, the power or the index should be a natural number. So the domain and codomain of this function is a set of the real number, and the index or the power should be a natural number, belongs to n. If the two conditions are satisfied, then this function is a polynomial function. We can write it in the form of a node plus a1x plus a2x power 2 and so on until an x power n. This is a polynomial function. As you can see, n or the power should be a natural number, and a node, a1, a2 or until an should be a real number. Okay, determine which of the following is a polynomial function and which is not. If not, mention the reason. So, if this function is not a polynomial function, we should mention the reason. Let's start with the first one, 2x plus 5. But at first, I want you to note that if I want to determine the polynomial or to determine if the function is polynomial or not, don't simplify the rule. Okay, we will deal with the rule as it is. Here, for example, 2x plus 5. Is it a polynomial or not? Yes, it's a polynomial. Why? The domain here and codomain is r or the real number. Also, the power here 1. 1 belongs to integers. So, belongs to natural number. So, this is a polynomial. The second one here, f of x equals root x. The domain here is not r. The domain will be r positive and 0. not or negative doesn't belong to the domain. So here this is not a polynomial. Why not a polynomial? Because the domain is not R. We can't write any negative number inside the square root. So the domain here is not R. Okay, n of x equals 1 plus root 2x minus 9x power 3. This is a polynomial. Okay, this is a polynomial because the domain is R. There is no number which can't be, no real number which can't be written here in the function. And also the power here 1 and 3 belongs to the natural number. So this is a polynomial. H of x equals 1 over x. Of course, the domain here equals r minus 0. So the domain is not r. So this is not a polynomial function. And the power of x is negative 1. So the power doesn't belong to the natural number. The power doesn't belong to the natural number. So this is not a polynomial because the domain is not r. And the power doesn't belong to natural number. Okay, the next one, x power 2 minus x minus 2. This is a polynomial, yes. K of x equals 8, also a polynomial. Okay, so the two conditions, if you have a function and you want to decide if this function is a polynomial or not, we have two conditions. The first one, the domain and codomain should be the real numbers. The second condition, that the index or the power should be a natural number, yes. So the domain and codomain are the real number, and the power or the exponential is a natural number. Okay, what about the degree of the polynomial function? The degree of the polynomial function is the degree of equation we studied before, or the degree of mathematics expression. Do you remember? So the degree of the polynomial function is the highest power of the variable in the function rule. The highest power of the variable in the function rule. A constant function here, for example, f of x equals a. This is a constant function because there is no variable here. A belongs to r minus 0. F of x equals a number. For example, f of x equals 2, f of x equals 3, f of x equals negative 1, or whatever, but except 0. Okay, so this function is, or this polynomial function is from 0 degree, as if you have x to the power 0. Okay, imagine that you have here x to the power 0, so this is from the 0 degree. Okay, but if the function f of x equals 0, not here any number except 0, but here if the function is f of x equals 0, in this case we say that this function has no degree. Okay, so f of x equals constant from 0 degree. If the function is f of x equals 0, it means that this function has no degree. Okay, when you want to determine the degree of the function, we should simplify. Okay, if we want to determine the degree of this function, we should simplify the function. Okay, so again, if I want to decide if a function is a polynomial or not, don't simplify. Don't simplify the function rule. If I want to determine the degree, I should simplify. Okay, let's take this exercise. Choose the correct answer. We have 3 questions. Let's begin with the first one. If the function f of x equals x times x power 3 minus 2, this is a polynomial function of which degree? So we have a function f of x equals x times x power 3 minus 2, and we know this is a polynomial function, but I want to know in which degree, of which degree this polynomial function. We said before, if I want to decide in which degree, I should simplify it first. So I'll multiply x times x power 3, then x times 2. Okay, So x times x power 3, then x times negative 2. X times x power 3 is x power 4. So x power 4 minus 2x. Let's see, from which degree? X power 4 here, we have x power 4 and x power 1. I'll take the greater. So from the 4th degree. So I'll choose 4th degree. This is the first one. Let's continue. The second one, if f of x equals 3 minus 5x. F of x equals 3 minus 5x. Then f of negative 2. How can I get f of negative 2? Just put negative 2 instead of x in the rule of the function. This is the rule of the function. Okay, I substitute here by negative 2. So 3 minus 5 times negative 2. 3 minus 5 times negative 2 is 10. 5 times negative 2 is negative 10. So we have 3 minus negative 10. It means 3 plus 10, which is 13. So I'll choose number 13. Question number 3. If f of x equals 4x plus k, and I know that f of 2 equals 15, I want k. How can I solve this? Yes, I'll substitute here f of 2, so I'll put 2 instead of x. And I know that f of x will be 15 if I'll put 2. It means 4 times 2 plus k equals 15. This is an equation. 4 times 2 plus k equals 15. 8 plus k, 4 times 2 is 8. 8 plus k equals 15, so k will be 7. So I'll choose 7. Okay, just put 2 instead of x, and I know that f of x will be 15. It's given here. F of 2 equals 15. So I'll put 2 instead of x. Then f of x will be 15. I'll solve this first order equation to get the value of k. We have another exercise. If f of x is 2x plus 5 and another function g of x equals x minus 6, then prove that f of 2 plus 3g of 3 equals 0. Okay, let's start with the left hand side. F of 2. How can I calculate f of 2? Where is the f of 2? Where is the function f? This is function f. This is the rule of function f. So I'll put 2 here instead of x. So f of 2 will be 2 times 2 plus 5. 2 times 2 is 4. 4 plus 5 is 9. So f of 2 is 9. So this is 9. Okay, 3g of 3. How can I get g of 3? I have g of x here, so I'll put 3 instead of x. But don't forget, here we have g of x, not f of x. So I'll substitute here in g of x. I'll put 3 instead of x, so it will be 3 minus 6, which is negative 3. This is g of 3. Okay, what about 3g of 3? I'll multiply g of 3 by 3, so it will be negative 9. So we have f of 2, 9. 3g of 3, negative 9. So this is negative 9. 9 plus negative 9 is 0. Okay, so f of 2 plus 3g of 3 equals 9. This is 9. And the 3g of 3 is negative 9. So 9 plus negative 9, which is 0. Okay, so today we studied the polynomial functions. We studied before the relation, and we said that the relation can be a function and the relation can't be a function. So any relation can be a function or not. The relation, if each element in the domain connected with one and only one element in the codomain, so this is a function. The function also can be polynomial function or not. Okay, it can be a polynomial function if the domain and the codomain are real numbers and the power of x is a natural number. Okay, so this is the relation, the function, and the polynomial function. I hope you have understood our session today. Thank you very much for watching. Next session we will study some polynomial functions. The lesson of studying polynomial functions will be two parts. Part 1, we will take part 1 next session. Thank you very much and goodbye.